Students, we were discussing the numericals from the chapter Thermal Expansion of Solids, and we have discussed three numericals, and we have started doing the fourth numerical. I will tell you that what we did till so far. Just repeating the question once again. The difference of the lengths of the two metal rods A and B is 0.25 meters at all temperatures. If the coefficients of linear expansion of the materials of the rod A and B are 1.28 into 10 to the power minus 5 per degree C, and the coefficient of the linear expansion of rod B is 1.92 into 10 to the power minus 5 per degree C. Find their lengths at 0 degree C. Okay, that means C. We have to find out this L part. Have you seen in both the sides of the equation we are having this L? Okay, just we have to find out this L part. So let's go through very short what we have done. Let the length of the rod A at 0 degree C be L meters. Okay. Now students, if you just go through the question, you can able to see that the coefficient of the linear expansion of B is greater than that of the A. So obviously students, the length of the B will be this. Why? L minus 0.25 meters, because see in the question, the first part, the difference of the lengths of two metal rods is given. So if the A's length is this, so what will be the length of the B? It has to be L minus 0.25, isn't it? So we have assumed the length of the rod B be this. Okay. Now students, we have assumed that the let the temperature increases by T degree C. See, I have written also the statement. If the temperature is increased by T degree C. So what will be the linear expansion of the rod A? It will be L into this your alpha part, that is your coefficient 1, coefficient of rod A, seen the question, into T. And for the linear expansion of rod B will be what? This length of the rod B, that is L minus 0.25 into your alpha part, this is your alpha part, seen the question, this one, into T, isn't it? Okay. So now what is given in the question? That as the difference of the lengths of the rods A and B remain same at all temperatures, so their linear expansion will also be same, isn't it? Because their difference in the lengths are maintaining at all the temperatures, so you can say that the linear expansion will also be equal. Okay. So since we have assumed that their linear expansion will also be equal, so we can write this equation. We can equate the two equations of the rod A and B, isn't it? So see, I've written this is for your A and this is for your rod B. Okay. So just find out, your T's will get cancelled from both the sides. Okay. So you will be left, you will find the value of L, and the length will come to as 0.75 meters. Okay. So the length of the rod A at 0 degree C is 7.75 meters, isn't it? I'm just writing here. So the length of the rod A at 0 degree C is 0.75 meters. Okay. And the length of the rod B at 0 degree C is what? L minus 0.25. That means your L value is now 0.75. So what? 0.75 minus 0.25. what it will be? It will be 0.50 meters. Okay, so your length of rod B is 0.50 and the length of rod A that we have calculated, the value of L is 0.75 meters is the length of the rod A. Okay, so very important students, this type of sum. Okay, you just go through the main theory that is given for the coefficient of linear expansion, students. Okay, if you just go through right now I'm talking about the theory part. Okay, which theory will strictly follow for this type of sums. The theory given for the coefficient of linear expansion regarding the numerical expression. Okay, that L2 minus L1 is directly proportional to L1. Okay, all these proportional steps. Next one, L2 minus L1 directly proportional to the T2 minus T1. You just read it separately. Okay, all are very important for your numericals concept. And finally, that we are writing for your alpha value. After writing all these proportionalities steps, we are coming to this particular step of alpha. That is, your alpha will be equal to your L2 minus L1 by L1 into T2 minus T1. Okay, repeatedly telling you all this. And finally, don't just stop till here. You just memorize, derive the value for your L2. Okay, L2's value will be what? I'm just writing here it only. Okay, this is the boundary of this sum. L2 will be, this is just for your numericals part, students. Okay, from the theory I'm writing L1 into, or you can keep 1 second bracket also, 1 plus alpha T2 minus T1. Okay, yes, so this value also it's better to memorize. Okay, after doing the derivation. Yes.